In this video, we'll see the solutions with explanations for Chapter 13, Exponents and Powers from Grade 7 IMO Olympiad Workbook. First question. What is 2 to the power of 3 plus 2 to the power of 3 plus 2 to the power of 3 plus 2 to the power of 3? This is a case of repeated addition. Repeated addition can be expressed as multiplication. Since 2 to the power of 3 is being added 4 times, it can be expressed as 4 into 2 to the power of 3. 4 is 2 square. So that becomes 2 square into 2 cube. Here the base is the same. So we can add the powers. Our answer becomes 2 to the power of 2 plus 3, which is 2 to the power of 5. So our option A is correct. You could also do the same question another way. 2 to the power of 3 is 8. 8 added 4 times is 32. 32 can also be expressed as 2 multiplied 5 times, which is 2 to the power of 5 again. This way also gives you the right answer, option A. Next, question number 2. Let's find the value of this expression. Let's simplify the first term. Minus 1 by 2 whole raised to 5 by minus 1 by 2 whole raised to 4. Here, the base of the numerator and the denominator are the same. So, the powers can be subtracted. So, this term simplifies to minus 1 by 2 whole raised to 5 minus 4, which is 1. So, it is simply minus 1 by 2. Now, we'll simplify the second term. Minus 1 by 8 by minus 1 by 4. Here we can convert the division to multiplication with the reciprocal. So what we get is minus 1 by 8 into minus 4 by 1. Minus into minus becomes positive. So we get 4 by 8, which is 1 by 2. Now our full expression becomes minus 1 by 2 divided by 1 by 2. Let's convert the division into multiplication by changing the second term to its reciprocal. Minus 1 by 2 into 2 by 1. Our final answer becomes minus 1, which is option D. Next, question number 3. Let's find the value of this expression. Here again, let's use 2 different ways. First method, we'll use the laws of exponents. In our expression, we'll multiply all the numerators together and the denominators together. What we get is a to the power of p into a to the power of q into a to the power of r by a to the power of q into a to the power of r into a to the power of p. In all the exponents, the base remains the same. So we'll simplify by adding the powers of the numerator. A to the power of p plus q plus r. Using the same property, the denominator becomes a to the power of q plus r plus p. Now again, the base remains the same. But since we have division, we'll subtract the powers. What we get is a to the power of p plus q plus r minus of q plus r plus p, which results in a to the power of 0, which is 1. So our right option is option A. Now let's see our second method. Here we can simply cancel out the similar terms in the numerator and the denominator. A to the power of p and a to the power of p gets cancelled. A to the power of q and a to the power of q will get cancelled, and a to the power of r and a to the power of r will also get cancelled, leaving us with a result of 1. Again, the right option, option A. Moving on to question number 4. Find the value of this expression. Let's carefully note that there is an addition in the middle. So minus 8 multiplied 5 times plus minus 8 multiplied 5 times again. According to the order of operations, we have to do the multiplication before addition. Multiplying minus 8 5 times gives us minus 8 raised to 5. So our expression becomes minus 8 whole to the power of 5 plus minus 8 whole to the power of 5. Now let's remember that when we have the base as a negative number, the answer will be either positive or negative. If the exponent is an odd number, it will always result in a negative answer. And if the exponent is an even number, the result will always be positive. In our case, the exponent is 5, which is an odd number. So the minus sign will remain in our answer. Now our expression becomes minus 8 to the power of 5 plus minus 8 to the power of 5. Since the same term minus 8 to the power of 5 is being added 2 times, we can consider it as repeated addition. So we get 2 into minus 8 to the power of 5. This can also be written as minus 2 into 8 to the power of 5. We have this as option A. But wait, option D says all of these could be the right answers. So let's verify that. Minus 2 into 8 to the power of 5 can be written as minus 2 to the power of 1 into 2 to the power of 3 the whole raised to 5. This is because 8 can be expressed as 2 cubed. That gives us minus of 2 to the power of 1 into 2 to the power of 3 into 5, which becomes minus 2 to the power of 1 into 2 to the power of 15. That will result in minus 2 to the power of 16, which is option B. So both A and B are correct. Now let's check if option C is right. Minus of 4 to the power of 8. 4 can be written as 2 square. So the expression becomes minus of 2 square the whole raised to 8. This again is minus of 2 to the power of 2 into 8, which is minus 2 to the power of 16. This is the same as option B, which is correct. So that means all the three options A, B and C are right. So the correct answer is option D. Now we move on to question number 5. If 2 by 5 whole to the power of minus 4 into 2 by 5 whole to the power of 12 is equal to 25 by 4 whole to the power of 6 minus 2x, then what is x? First, let us simplify the left side of the equation. 2 by 5 whole to the power of minus 4 into 2 by 5 whole to the power of 12. Here our base is the same, 2 by 5. So we can go ahead and add the powers. So our expression becomes 2 by 5 whole to the power of minus 4 plus 12, which is 2 by 5 whole to the power of 8. Now let's write the power 8 as 2 into 4. In that case, our expression can be written as 2 to the power of 5, the whole square, the whole raised to 4. Now let's compute 2 by 5, the whole square. It becomes 4 by 25. Can you figure out why we did all of this? This is to match the base on both the left side and the right side of the equation. But wait, on the left side it is 4 by 25 and on the right side it is 25 by 4. So it is the reciprocal of each other. If you have learnt negative exponents, then you will know that if the base is changed to its reciprocal and the exponent is changed to its inverse, then the value is the same. So our equation becomes 25 by 4 whole raised to minus 4 is equal to 25 by 4 whole raised to 6 minus 2x. Now the base in both the left side and the right side are same. So the exponents have to be equal. So minus 4 is equal to 6 minus 2x. That gives us 2x is equal to 10 and x is equal to 5. So our right option is option C. Next, question number 6. Let's find the value of this expression. Let's do this using two methods. We'll check out if we can solve this without using the laws of exponents. To begin with, we'll keep the first expression as it is and solve p to the power of x divided by p to the power of y. We'll change the division to multiplication with the reciprocal. P to the power of x into 1 by p to the power of y. That becomes p to the power of x by p to the power of y. Now let's convert the division here to multiplication and change the following term to its reciprocal. So what we get is p to the power of x into p to the power of y into p to the power of y by p to the power of x. Here p to the power of x on the numerator and the denominator cancels itself. So what we are left with is p to the power of y into p to the power of y. Finally, we'll have to use the laws of exponents. The base p remains the same. So we add the powers. What results is p to the power of y plus y, which is p to the power of 2y. So we get our right option of option D. Now let's check out another method to solve the same problem. We will use the laws of exponents wherever it is possible. P to the power of x into p to the power of y becomes p to the power of x plus y. P to the power of x divided by p to the power of y will become p to the power of x minus y. Here again our base is the same. So division will mean subtracting the exponents. What we get is p to the power of x plus y minus of x minus y. Removing the parenthesis in the exponent, we get p to the power of x plus y minus x plus y. That becomes p to the power of y plus y or p to the power of 2y. That verifies that the correct answer is option D. With that, we move on to question number 7. Select the correct match. Here, before we find the value, it is easier for us to check the base. 3 to the power of 4 has the base of 3. 2 to the power of 5 has a base of 2. But the option tells us that the base is 5, which means option B cannot be correct. So let's rule it out. Next, 4 to the power of 3 has a base of 4. And 5 square has a base of 5. So let's find the values of options A, C and D. Option A, 3 to the power of 4, which is 3 multiplied 4 times. 3 into 3 into 3 into 3 will result in 81. But the value given is 87. So, option A cannot be the right answer. Moving to option C, 4 cube is 4 into 4 into 4, and that is 64. So the value given in the question matches with the answer. So we have C to be the correct match. Let's find out if option D is also wrong before we mark the right answer. 5 square is 25. So D cannot be the right answer. So now we can confirm that the right option is option C. Next, question number 8. Standard form of the number 79,403.75. When a number is in its standard form, we know that the first number should have the decimal point placed after a single digit. In this case, A and B can be eliminated because A has 2 digits before the decimal point and option B has 3 digits before the decimal point. So options A and B are incorrect. Now coming to our question. 79403.75. Now let's move the decimal point to the left one step at a time. So to reach 7.940375, we need to move the decimal point 4 times. And that means to keep the value unchanged, we multiply by 10 to the power of 4. This means that the right option is option C. Next, we move on to question number 9. Using the given equation, let's find the value of A. First, let's write the equation as it is. Then, we move the division by 6 from left hand side to the right hand side. What we get is 2 to the power of 4a minus 3 plus 10 is equal to 7 into 6. 2 to the power of 4a minus 3 plus 10 is 42. Moving the plus 10 to the other side results in 2 to the power of 4a minus 3 is equal to 42 minus 10. So 2 to the power of 4a minus 3 is 32. Now let's pause and think. In the left hand side, we have a variable on the exponent, and on the right side, we have a constant. What we can do is to express 32 as an exponent with the same base 2. 32 is the same as 2 multiplied 5 times. So that can be written as 2 to the power of 5. Our equation becomes 2 to the power of 4a minus 3 is equal to 2 to the power of 5. Here, since the base remains same on both the left hand side and the right hand side, the powers also have to be equal. So that means 4a minus 3 is equal to 5. 4a is 5 plus 3, which is 8, and a becomes 8 by 4. So a is equal to 2, which gives us the right option of option D. Now, question number 10. Study the following statements and select the correct option. Here, we need to find if the statements P and Q are true or false. So, let us start with statement P. 3 square is greater than 2 cube. First, let's find the values. 3 square is 9 and 2 cube is 8. Obviously, 9 is greater than 8. So, statement P is true. Now, let's check out statement Q. Minus 1 by 2 the whole square is less than minus 2 the whole square. Let's remember, we have a negative sign in the base and the exponent is an even number. In such a case, the answer becomes positive. So minus 1 by 2 the whole square is positive 1 by 4 and minus 2 the whole square becomes positive 4. So now our statement simplifies to 1 by 4 is less than 4, which is again true. Since both P and Q are true, the right option is option A.